Hey, what's up guys? Welcome to the third lesson in C++ in 2021. Now I was going to go over the optionals this time, as I mentioned in the end of the last lesson, but I figured that that was optional and I would actually do operator overloading this time because it ties into the spaceship operator and why it was introduced into the language for the most part, from what I understand. So one thing that I thought I would mention was that at the end of the last video, I mentioned that it seemed like there was a bug with import compare where it was needed from within this module here, right? So it uses compare within here, but it's not accessible out here and it doesn't compile. Now this, according to Microsoft, is intended. This is not the one I wanted, this one. I reported the bug and it's not a bug, it's by design. It's because when you generate your templates at compile time, because that's when templates are generated, we'll probably get into templates in another lesson. It basically, at least for the purposes of this, I believe it basically builds your templates here. And since compare is not accessible here, then it throws these errors. Now the workaround that they offered, which is makes sense, is if you go inside here, you can export your imports, and that will make them available out here. It seems like I'm not the only one who thinks this is weird because he uses, unfortunately, it's by design, it's part of the standard, so it might be something that gets rectified or looked at in the future, because I imagine that people are going to start running into this as modules become more and more adopted, and it'll annoy the powers that be, and it'll get changed, I imagine. So in this lesson, what we're going to do is we're going to implement our own vector class and overload all the operators associated with it so that we can do what you would kind of get out of like a GLM type package. We might actually end up using our own custom in-house vector class for some stuff that we do in the game engine series. I don't know, we'll see. So without further ado, let's jump right into the lesson. And before we do, just, hit that subscribe button, like, comment, all that crap, and let me know what you're looking forward to learning in this series. Okay, so the first thing we're going to do is we're just going to do a little bit of cleanup here. We're going to remove this hello world stuff. If you didn't know, I do have a GitHub repository with these lessons in it, and you can just check out the tag that you're interested in. And one thing that you might run into is I forgot to save the language standard as part of the solution file, apparently. So when you download, just make sure to go into properties like I showed you and change it to the ISO C++20 standard. And again, if that's not there, download the preview version of Visual Studio. All right, so let's clean up a little bit. So let's remove, we'll also delete it. And spaceship operator, we don't actually need the file anymore. We'll delete that as well. We can remove this, and now we're going to start actually building some. We're going to actually start building some useful modules. So the first thing we're going to do is we're going to create a new filter, and we're going to call this. Let's call it types. And inside types, we're going to create a new module, and we're going to call this module vector3. So that's module vector3, and what this is going to be is it's going to be a basic vector3 struct type. So I don't know if it's the newer. Why am I having so much trouble forgetting the syntax of this for some reason? Major brain fart. Anyways, I don't know if it's the new preview version I just updated. There was a new preview version released today, but IntelliSense seems to be a lot nicer today, so it might be worth it to upgrade at this point. So vector3, it's going to have a series of floats, and it's going to just have XYZ. We're going to actually initialize these to 0. X, Y, and Z. Initialize them to 0. And we're going to do some operator overloading on here. Okay, so before we get too into it, I'm going to go over a few guidelines on how we're going to do operator overloading, where you should put your operator overloads, because there are two main types. The two main types of overloading are going to be member overloads, like that go within the class itself or the struct. And the second type will be global scope overloads, which will go in the global scope. Knowing when you want to do both of these things is you'll get a feel of over time. I'm taking a lot of my cues out of, again, the Professional C++ book that I've been recommending. Links down below. You'll get a feel for it. I'll give you the gist of how I understand it, how you want to do it. So let's add some comments here just to add some explanations. So there are some operators that you can only do as a member variable. There are some operators that I believe you can only do as a global function. I'm not going to go over too much of those or any of them. There's going to be more videos going over operator overloads in the future, probably just not the next video. So the main property of your operators that is going to dictate where you put your member overloads is what the left-hand operator is. That's going to be the main dictator. So for example, if you're only ever working with the same type, so if your two operands, I believe they're called, are the same type as your object, then you can probably always do it as a member overload. So for example, let's say you have a vector 3 and you're creating a vector, we'll call it new vector, and this equals vector 1 plus vector 2. And since both vector 1 and vector 2 are the same type, this can actually be inside here. So we can say that vector addition is a member function, and by extension, vector subtraction is a member function. There. Now, if you wanted to, say, multiply it by a scalar. So when you're scaling a vector, you're going to do like a vector times a number times 3, which is a scalar. So that would look like this. Vector 3, new scaled vector, equal, let's say, vector 1 times 2. Now this form would actually work as a member variable as well, because you have the vector 3 type on the left hand as the left hand operator. So here, left hand operator is type T, and this is type T. So type T equal vector 3. Now let's just say let, just to be clear. So this will work as a left-hand operand here. So we can do vector times scalar is a member function. However, if we were to do it, to flip that around and do 2 times vec1, this no longer has a vector as its left-hand operand, right? So what you would need is a vector overload, or a global operator overload to handle this case. So then you would have scalar times vector is in global scope. What other operations do we have? So one thing that tying into the spaceship operator we were talking about before, and also let's extend this. Divided by scalar is a member function, and scalar divided by, you can't actually do a vector divided by a scalar divided by a vector, so we can get rid of this. And this is actually a good case of why these are separated, right? So here you can allow divide by scalar but you can disallow scalar divide by vector, right? So that's actually a good use case on showing why these are actually separated. Now there are some tricks you can do to get around some of this where you only need to write it once, but if you're mixing types, you're often going to need to write it twice, and that's okay. The next thing we're going to want to do is be able to compare the vectors, right? You want to know which one's bigger, so we're going to need the magnitude. So let's write a function here. Let's say float, I believe it's called the magnitude. And what this is, I'm not going to actually return anything. Actually, I will. So we're going to import the CMath because we're going to need it, right? So we're going to return the stud.squirt. Is it just squirt? Yeah, I guess it's just squirt. So this is going to be x squared plus y squared plus z squared, right? So that's how you get the magnitude of a vector, right? So we want to be able to compare whether or not two vectors are bigger or smaller or equal to each other. So what we can do is overload the comparison operators. And to do that, comparison operators are always done as a member function. Comparison operators are always done as a member function. And this is actually where the spaceship operator reduces a whole lot of work. So I'm not going to show you exactly what it looked like. To do all the comparison operators in the past, I believe you had to individually overload every single comparison. So that would be greater than, less than, equal to, not equal, greater equal, smaller equal. You'd have to do all 6 of these individually. That's 6 overloads. With the spaceship operator, you sometimes only need to do 1 if it's a simple type. So let's say it's trivially comparable, right? So I don't know exactly how what it does internally with structs and classes, but let's say you only had the x. Let's not get rid of it completely, and this is going to throw an error. Anyway, let's just say you only had the x. Then you'd be able to compare this object trivially, and you'd be able to just do a default overload, a default spaceship operator overload. So you'd be able to do it, and what that will look like, I haven't shown you the syntax yet, but we're not going to be able to use the default for our use case, so I'm just going to show you what it looks like. So it would look something like, it would be bool, it would be partial std, we need the compare package. Sorry. So we'd import compare. We're going to need it anyway, so might as well do it. So we do std partial ordering, because remember, if we're comparing floats, then we want to return a partial ordering. Then we do partial ordering operator, spaceship operator, and it would be const vector 3 and right hand side const equal default. And I believe that's all you would need to do. Yeah. So this would give you a default operator. And this would overload and give you all 6 of these comparison operators automatically using the fields by default. Now, our case is different, because when we do the comparison, I'll just comment that out. When we do the comparison, we're going to need to do some custom logic on exactly what we're comparing. So if we're not using the default, spaceship, if we're not using default spaceship operator, then we also need to override or overload or define, whatever you want to call it, the equals operator. We also need to overload equal operator. Now, this is done because, mostly because it's just not handled in automatically. It's not generated by the compiler if you put a custom overload for the spaceship operator. One nice thing is that in C++ 20, I don't know if it worked earlier, but now two things are true. One, I believe that it understands that you can flip the order of the operands. So you can do, so let's say here we have bool equals, and let's say our vector is reducible into just a number, right? And we want to compare that to another number. So we could do vec1 equals 3, right? Now I believe that C++ 20, the equal operator, will automatically make it so you can do this, just as a convenience. One thing that is 100% true though, that used to not happen, but does happen now, as you see here, you used to have to overload both equal and not equal. In C++ 20, the compiler knows that equals is not equals. It understands that not equals is not equals. So it generates that for you automatically. So if you're not using the default spaceship operator overload, then you need to overload the equals operator as well. All right, so I think that's enough theory. Let's actually just go and do it. So I gave you a taste earlier of what the operator overload syntax looks like, but let's do it one at a time. So let's start with addition, because this one's going to be simple. So the first thing you're going to do is you're going to want to choose a return type. Now in our case, we're going to be returning a vector 3. Then we're going to choose the operator we want to overload. So we use the operator keyword, and then followed by the operator you want to overload, which is the plus sign. When you're doing a member variable, the first operand inside is going to be your right-hand operator. So you can decide whether or not you want to do everything by value or by reference. I like to, at least for a lot of stuff, I like to make copies. So you're going to do, let's uncomment this. So as our operand, we're going to go constant vector 3 reference. And a lot of people, you'll see a lot of times that they use RHS for right-hand side just to be explicit, right? So let's expand that, and we can return it, right? So I like to use a newish, I believe this is also C++ 20 syntax, where you can .x equal, and then we'll do x plus right-hand side .x, comma, .y equal y plus right-hand side .y, and .z equal z plus right-hand side .z. And you see now, when looking at this operator, that it's much clearer exactly what it does. Simple enough, right? So one caveat with this syntax is it needs to be, the naming, it needs to be in the same order as it's declared here. Now I don't know, will it warn me? Yeah, so actually Visual Studio is nice. It actually warns you out of order initializers are non-standard. So that's our plus operator. Now we'll do the subtraction operator, and then we'll do we'll jump out for a minute and do a special operator overload that I believe the Cherno also showed in his video, but I ended up knowing it existed and Googled it, and I think I remember how to do it. So we'll try that. So the first thing we're going to do is add the subtraction. Now the subtraction logic is basically the same, but we change the operator to minus. And you can, I believe you can also add a space here as well if you like separating them, but you'll usually see them stuck together. So yeah, so you just do minus inside here, and then we've got our subtraction. Now to show off that these are indeed working, what we're going to do is we're going to overload the, I believe it's called the stream operator. I don't know. It's the double shoot. It's the shoot operator. When we std count, we use this. This is the operator we're going to overload. Since our left-hand variable, our left-hand type is not vector. Remember, our vector's left-hand operator, operand, is of type T. Since it's not of type T, it's going to be of type, I believe it's going to be OStream. We need to make it a global operator, and we'll throw that together. So first thing we're going to need to is we're going to need IOStream, because what we want is in there. So what we're going to do, I believe it's std OStream constant reference, or just a reference, and then we want to overload the double shoot operator. Now, the global syntax is going to be, you're going to have your left-hand operator, so it's going to be the same thing. OStream, and then your right-hand operator is going to be the type that you want to overload, vectors. And this one, you can actually just make it a const vectors3 reference, and we can call it right-hand side as well. That looks okay. So now, all we need to do here is we return OS, and then we can build our string. So we will add this, and then right-hand side dot x, and then comma, right-hand side dot y, comma, right-hand side dot z, and then close it off. And I believe that is all we need to do. Now, one thing with your operator overloads in the global scope, since we're in a module, we need to remember to export them. So now we have a vector class with 2 operators overloaded, and also the OStream operator working. So we should be able to go into our main.cpp and import vector3. We'll create a couple of vectors, vector3, and again, dot x equal, let's say 1, dot y equal 2, dot z equal 3. And now we're going to make the next, stop it, IntelliSense, you're dumb. I wish CMake had module support, otherwise we'd be in CMake. Anyway, so we should probably give these names, vector1 and vector2, right? Okay. So now we can start playing with our operators. So we're going to import IOStream. Now we should be able to std count and vector1. Now we're just going to build that to make sure that our vector OStream is working. And line, is not defined. And it looks like it worked. And see, it printed out properly. So that's how you define your output streams. So let's play with our operators now. So we know that this one's working. So our test output operator, and then we will addition subtraction. So we can do this, vec1 minus vec2, or we should do plus vec2, and line, std count, vec1 minus vec2, std and line. And there we go. And you'll see now that we have 444, which is correct. 1 plus 3, 2 plus 2, and 1 plus 3 is 444. And then 1 minus 3 is minus 2, 2 minus 2 is 0, and 3 minus 1 is 2. So we know that all of our operators so far are working exactly as intended. Now we want to do the scalars, so we're going to mix a couple types together. So the scalars are going to be almost exactly the same thing. We're going to return a vector 3. It's going to be an operator star because it's a multiplication. And instead of taking a vector 3, we're actually going to just take a float scalar. And again, we'll just call it right-hand side. And again, we can call const because we're going to be creating a new variable. So let's finish this off. We are just going to return a new vector 3, and .x will be right-hand side. .x. .y will be right-hand side. .y. And .z, it will be right-hand side. Oops. Times z. And that will be our scalar multiplication. Our scalar division will do pretty much the same thing, except we're actually just going to reuse this one up here, just because I like that, doing it like that. So you can do this star, or star this, star this, divided by 1 divided by right-hand side, times 1 divided by right-hand side. So that will be our scalars, and now I'll show you those in action. So we'll test multiplication, scalar, multiplication, and division. So we'll take this and we'll add them to the bottom here. So we will multiply this by 2, and we will divide this by 2. Now these two should work no problem. Let's hit play. And you see here 2, 4, 6. So 1 times 2, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and again it was vec1, so 1 divided by 2 is 0.5, 2 divided by 2 is 1, and 3 divided by 2 is 1.5. So that works exactly as expected. Now, we know that you can multiply in both directions, right? So let's try doing that and see what happens, right? 2 times vec1. And you'll see immediately there's no operator that matches it. You don't even have to try building, but if we try building, you'll see there's no operator that matches it. And this goes into the fact, like what I explained, that your left-hand operand always needs to be of type T if your operators are member functions. So to fix that, we will basically take this multiplication here. We will go down and scalar vector here. Now we just need to add the left-hand operand. So the float is the one we're fixing, so left-hand side, and then we are taking a vector 3 as our right-hand side variable. So here we go, .x. Here, we'll take this, copy this down because it's all right-hand side now, and this is all left-hand side. And take this dot off. Now that should, yeah, and that works. And it can't be const because it's not a member variable anymore. So now this will create a new vector that will multiply left-hand side. The warning goes away. And just to show here, we build that. Oops. No global operator found which takes type vector 3. Oh, so as I mentioned before, since it's in a module, so now with export at the beginning, we should be able to run it, and you'll see that it worked just as intended. All right, we're almost done. The last thing that I'm going to go over in this lesson are the comparison operators. Now, they're very similar. I already showed you the syntax of the operator. Since we're always going to be comparing two vector 3s, it can be a member variable. So for a vector 3, what we're going to be comparing is the magnitude. Now what you could do is you could do this magnitude return this magnitude spaceship operator, and then right hand side dot magnitude. Right? And why can't I? The object has qualifiers that makes it, I think I want to make it const. Is that what it's complaining about? Yeah, I just need to make it const. So I could do it like this. Now, because I'm me, and because everyone should be aware of this, if you're doing a comparison between vectors, you don't need to use this expensive squirt function. So you can grab this, and we're going to actually make a float relative magnitude const, and what this is going to return is just the powers, the squares added together. Now the reason we do this is because squirt is expensive, and we know that we can balance the equations. If we don't need to know the actual number, we know that if this equals this, then this will also relative equal this, because we can just square the whole thing, which means that these two are comparable to each other. So if one's bigger than the other, then it's still going to be bigger in the long run. So we're going to do that. So inside here, we're going to say relative. Is it relative? Yeah, relative magnitude and relative magnitude. Did I make that const? I didn't. I did. Good. And we have the ordering here. Now, as I mentioned, if we're overriding the spaceship operator with something that's not default, we also need to provide the equal operator. So I also noticed that I need to remove const vector end here, because the equality operators are going to do it this way. So let's continue on making our equal operator. So operator equal, and we will make also vector 3 right hand side, and this one, it's basically the same. This relative magnitude equal right hand side relative magnitude, and there we go. Now we'll just build that to make sure it builds. Can you tell this is a second take? I forgot to delete some stuff, but you'll see this in a minute. All right, and it builds. So with these done, what we're going to do is actually, let's go back to where I just was. We've got our comparison operators. So we'll actually test those here, and instead of typing it all out, you'll see that I also tested it here. Now I'll remove this. And I don't know, because order of operations is the thing, these need to be booleans. And that should build. That builds fine. And this is basically so that it's doing this implicitly. I'll show you the explicit cast. So it's doing a bool. So what we did here is vector 1 equal vector 2, which it's true. Vector 1 is bigger than vector 2, which is false. Vector 1 smaller equal to vector 2, which is true because it's equal. And vector 1 not equal to 2 times vector 2, mixing a couple of operators together, which is true, because this will be double the magnitude, because it's times 2. So let's run this, and you'll see we have 1, 0, 1, 1. So a Boolean is printed as 1, and false is printed as 0. Now let's say we wanted to have that print actual letters. What we can do, and I don't think I can override the default operator for bool doing this. So what we can do is inside here, we can create a wrapper class in the default namespace. So we're going to call it bool wrapper. And this is what you saw that I just deleted. Struct bool wrapper, which will just have a bool value. With this bool wrapper, we are going to overload the OStream. I've already imported it because second take, but I've added this import string. And within here, what we're going to do is we are going to say text, and we're going to say string text equal right hand side. It's not going to be right hand side. This is actually going to be a Boolean. So it'll be right hand side, question mark, and it'll be true, and else it'll be false. Now this, in theory, would have printed true or false if the bool operator didn't already exist. So let's just try building this, and you're going to see it says is ambiguous because this operator already exists. So that's what our bool wrapper is for. So instead of taking a flat bool, we're actually just going to take our bool wrapper. Okay, so this is the error that we were having. You cannot convert from const bool wrapper to bool, right? So what we want to do in this case is provide a conversion operator to our struct to automatically convert to Boolean when referencing a bool wrapper in the context of a Boolean, as we are here. Right, so we're expecting a Boolean here, but it can't implicitly convert to Boolean unless we do put the operator keyword, the type that you want to convert to, and you can either do a bool or a bool reference. I'm just going to do a bool, and you need parentheses, and you can return your value. And we'll build that. And still can't convert bool. Const bool wrapper to bool. So we can do const. So maybe we can do this now. Yeah, okay, so that's what it was. We just need to ensure that it's keeping const correctness, which is what we want. So this returns a bool, and that works properly. Now, if we go in here, we can put a bool wrapper here. Build that, and you'll see that that now prints as true. Now we can see if it works. Define bool wrapper, and then undef bool. Yeah, and that works like that. So if you wanted to replace all of the bools inside your entire application with the bool wrapper, then you could do this type stuff. You can probably do this up here. I would do it like this because I believe that's where they want you to put preprocessor commands, and then you can undef bool here. Will that work? Global can't do it there. How does that? And this works fine. This works perfectly fine. And because of modules, and this is one of the reasons modules is great, is this is not going to leak into all of the other stuff. So normal headers would just paste all of the vector3 code inside, and then everywhere inside here, which references a bool, would be replaced with bool wrapper. And you can see how that makes a problem. But because we have modules, we can basically define our own classes that have. So if you wanted to always print true or false, this is one way of doing it. I don't know if there's another way, but this way works. So like you can have a types bool and do that here, and you can have a an include file that overrides everything. So that's everything that we're going to look over for operator overloading. I know this was probably much longer than I meant it to be, but this was a much larger topic than I meant it to be originally, because I went into this wasn't planned and this wasn't planned, and actually the whole 15-minute theory section at the beginning wasn't planned. I realized that in-depth explanation was probably warranted, so hopefully you appreciated that. So if you liked this lesson, you like the effort I've been putting in, hit like, subscribe, all that crap, and I'll see you next time.